Hello, this is Professor White. Today we will look at bearing. There is another bearing section in the application of right triangles, but this one is actually considering two different approaches of defining bearing, so you may want to watch both of them. Let's get started. You can talk about bearing two different ways. One way is direction to a point from a previous point. And you usually do that with knowing which directions is north, south, east, and west. And you start with A, you end up with B, and you always define it starting from north or south, and you go from A to B, and here's how much it went from the south, and you can say, well, this is the bearing of, let's say this is 50 degrees, this is south 50 degrees, and I went towards east. That's one way. Now you can also define the bearing, so it doesn't matter, it's clockwise or counterclockwise in this approach. This one is always from north in clockwise direction. And usually they do not specify north-south for that one, and they will just say bearing of 130 degrees. Okay? What is that? What is that? So what you need to do, same thing, east, west, north, south. Now, bearing of 130 degrees, so this one is 90 and other a little more. So this one is simply 130 degrees. And actually this is the same as the other one, right? Because this is 50 degrees. And we did define it from A to B again. But this time we just say bearing of simply 130 degrees. And somehow people know that it is from north. Okay? So, let's do a problem. So I'm going to write it out. I apologize for my handwriting. Two friends went boating. Okay, first friend, John, headed out bearing of south 42 degree east, going 36 miles per hour. He is on some kind of moped or something. Jane headed out due south. Here's a word. Going 40 miles per hour. How far apart are they? After 1.5 hours. All I need to do is draw a picture. North, south, east, west. They start together. Jane goes south, going 40 miles per hour. And John goes a little slower. He's going 36 miles per hour. And he is going south 42 east. And what are they asking me? They're asking me this distance. Now, let's look at this. What kind of problem is this? Just start with the real life problem and then go to trig problem. Here's my real life problem. I'm going to draw the trig problem now. I need to find out how much Jane traveled. Let's call that A. So A traveled, the distance, 40 miles per hour times she traveled 1.5 hours. So she actually traveled 60 miles. John, let's call it B. He was going 36 miles per hour. He also traveled 1.5. That will give me, let's see, how much is that? 54 miles? Let me make sure I did it in my head. 36 times 1.5. 54, very nice. Okay, so it's 54 miles. Now I'm going to draw my triangle. Due south means straight south. 60 miles. And this one is, so that's my A. This one is B, and this is 42. And B traveled for 54 miles. What kind of triangle is this? Remember, you have to watch the SAS, SSA, those videos before you do this problem. I know the side, angle, side. So this one is an SAS triangle. So how do I solve an SAS triangle? This is A, B, and C. This is simply an SAS triangle. So for the SAS triangles, go watch the SAS triangle section. I use the cosine law. Now I'm going to write the cosine law in terms of C, A, and B. Okay, here we go. C squared, that's going to be A squared plus B squared minus 2AB cosine of between the two of them. Let's say this is alpha. Now I'm going to plug in the numbers. C squared, A squared is 60 squared, plus 54, oh that's not degree, hold on. That one is miles. 54 squared minus 260, 54 cosine of 42. You can do that in one swoop. Let's go in there and I will go and enter that. So let's turn this off. Okay, so I need to enter. Let's clear everything. I need to check that my mode is in degree perfect. 60 square plus 54 square minus 2 times 60 times 54 times cosine of 42 degrees. That is actually C squared. I need to take the square root to the 0.5. That gives me 41.24. Alright, between this one where we use the cosine law and the other one where we use the Pythagorean theorem, if we are looking at the right triangle, you can just actually do a lot of problems related to bearing. Just make sure that you do draw a picture and understand what's going on.